I want to start with something that's already happening today, not some hypothetical future. You ask an AI coding agent to add user authentication, implement password reset, and add rate limiting. Then it starts working. It reads the repository, modifies multiple files, runs tests, and opens a pull request. And nobody typed every line manually anymore. But this is the part these demos usually skip. Did the AI store passwords correctly? Can password reset tokens be reused? Will rate limiting still work when the application is running on 5 different servers? And what happens when a real user or real attacker does something that wasn't mentioned in the prompt? The code can be generated in seconds. The consequences still belong to someone else. Usually, they belong to you. The AI wrote the feature, the engineer inherited the risk. And honestly, I think this is the quiet change happening in software development right now. AI isn't just suggesting the next line in your editor anymore. It's starting to handle tasks that used to belong to junior developers, mid-level developers, and sometimes even entire teams. And what's interesting is that most developers are already using these tools, while many of them still don't completely trust the output. According to Stack Overflow's developer survey, 84% of developers were already using AI tools or planning to use them. At first, that number sounds like complete confidence, but it isn't. The same survey found that AI responses that are almost right but not quite are still one of the biggest frustrations, and 45% of developers said that debugging AI-generated code can actually take longer than writing the code themselves. So maybe the real shift isn't that AI writes all the code and programmers disappear. Maybe the shift is that AI writes more of the first draft, while developers spend more time deciding whether that draft should even exist. This is what I want to talk about in this video. Not the claim that programming is dead, not the idea that one prompt can build a perfect production system, and not the assumption that nothing important is changing. Programming is gradually moving away from manually writing every line of code and toward directing systems, reviewing AI-generated work, and taking responsibility for what eventually gets deployed. I want to look at 3 changes. First, how developers are moving from writing code toward reviewing and validating it. Second, how coding assistants are becoming agents that can work asynchronously, modify entire repositories, and open pull requests on their own. And third, why the biggest disruption may be happening at the bottom of the career ladder, where junior developers traditionally learn the job. If AI starts doing the routine work that junior developers used to do, there is one important question underneath all of this. Who becomes the next senior engineer? And by the end of this video, I want to answer another question that matters whether you are learning programming, already working as a developer, or hiring engineers. So the question is, what becomes more valuable when writing code is no longer the scarce resource? I don't think the answer is simply better prompting. I think it's technical judgment. The ability to define the right problem, the ability to give AI the right constraints, the ability to test the result, to recognize something that looks correct but isn't, and to know when software is actually safe enough to deploy. AI isn't quietly eliminating programming. It's changing what we consider programming. Let's start with the most obvious change. AI is taking over more of the typing. Boilerplate code, database queries, AI endpoints, unit tests, documentation, refactoring, routine integration. Tasks that used to take hours can now produce a first draft in seconds. But software engineer was never just about typing syntax. The difficult part was always deciding what should be built, how it should behave, what could fail, and whether it would still work 6 months later. Let's take something simple, like a login system. An AI can generate routes, create a database model, implement password hashing, managing sessions, and write tests. It might even tell you that every test passed. But does it understand your actual security requirements? Did it protect against account enumeration? Can password reset tokens be reused? Are sessions invalidated after a password change? Will this design still work across multiple application servers? And did the tests actually cover dangerous scenarios, or did they only verify the happy paths? This is why AI-generated code creates a completely different kind of workload. You might write fewer lines of code, but you'll probably spend more time reading diffs, reproducing bugs, checking dependencies, designing tests, and investigating code that is almost correct. And honestly, almost correct can be much harder to deal with than code that's obviously broken. That 45% statistic describes the productivity paradox pretty well. AI can make the first draft dramatically faster, but if that draft contains subtle mistakes, the work doesn't disappear. It just moves somewhere else, into code reviews, into testing, into debugging, into security reviews, into maintenance. So the first quiet change is this. The value of a developer is moving away from producing every line of code and toward understanding whether those lines actually belong in the code base. Here is where things become more complicated. You'll often hear people say that AI makes developers 30% faster, or 55% faster, or twice as productive. The problem is that productivity depends completely on what you are measuring. In one controlled GitHub experiment, developers completed a programming task 55.8 faster while using Copilot. That's an impressive number, but it was also a constrained task with a clearly defined objective. Nobody was redesigning a legacy application. Nobody was trying to understand 10 years of undocumented business logic. Now compare that with a METR study that looked at experienced open source developers working on real tasks inside repositories they already knew. In that study, developers using early 2025 AI tools actually completed tasks 19% slower. What even more interesting is that those same developers believed that the tools had made them roughly 20% faster. At first, these results seem contradictory, but I don't think they are. AI works extremely well when tasks are repetitive, clearly defined, and easy to verify. It becomes much less predictable when a task requires deep context, careful investigation, or modifications across a large, unfamiliar code base. If you are creating a small API endpoint, generating a database migration, or writing a familiar unit test, AI can save you a lot of time. But if you are debugging a production issue inside a million-line repository, AI might confidently suggest 5 different fixes, and none of them may solve the actual problem. So the right question isn't whether AI makes developers faster. The real question is faster at what, for which developers, on which code base, with which review process, and are we measuring only code generation or the entire process from implementation to deployment and maintenance? The lesson here is pretty simple. AI isn't a universal productivity multiplier. For some tasks, it's a force multiplier. For others, it introduces additional complexity. The next change is even more important than autocomplete. For years, coding assistants lived inside the editor. You wrote a command, the assistant suggested a function. Then we moved into a chat-based development. You asked a question, the AI generated a file or explained some code. Now we are entering the agentic phase. An agent can inspect a repository, create a plan, modify multiple files, execute commands, run tests, respond to failures, and open a pull request. GitHub's Copilot coding agent can work in the background inside its own environment and request human review after the pull request is ready. OpenAI introduced Codex as a software engineering agent designed for longer and parallel tasks. Anthropic is moving Claude Code in the same direction, toward more autonomous development workflows. And this changes the actual unit of work. It's no longer just write this function. Now it's more like implement this feature across the repository, update the tests, preserve backward compatibility, and prepare a pull request that's ready for review. That might sound like a small change in wording, but I don't think it is. One developer may eventually coordinate several agents at the same time. One agent fixes a bug, another updates documentation, a third migrates a query, a fourth reviews a pull request. But delegation creates another responsibility. You have to decide what an agent can access, which files it can modify, which commands it can execute, which tests must pass, which permissions it receives, and when a human has to approve the next step. An autonomous agent is not an autonomous company. It doesn't automatically understand your business, your legal requirements, your customers, your undocumented dependencies. It can execute a plan, but it still cannot be trusted to create the right plan without supervision. This brings me to what I think is the most uncomfortable part of this discussion. What happens to junior developers? For decades, the learning path was relatively straightforward. You started with simple bugs, small features, tests, documentation, maintenance work. You made mistakes, a senior developer reviewed them. And over time, you develop the judgment needed to work on larger systems. But what happens if AI starts doing most of that work? What happens if small bug fixes are delegated to agents? Simple features are generated automatically, tests are written by AI, documentation comes from another agent, the work becomes more efficient, but the learning path becomes much less obvious. A Stanford analysis found that workers between 22 and 25 years old experienced a 30% relative decline in employment in occupations that were highly exposed to generative AI between late 2022 and May 2025. For early career software developers, employment fell by almost 20% compared with the late 2022 peak. At the same time, employment among workers aged 30 and older in those same occupations actually increased by around 60% to 12%. Now, these numbers don't prove that AI alone caused the decline. The technology industry also experienced layoffs, hiring freezes, higher interest rates, and a broader market correction. But I think the pattern is difficult to ignore. The strongest pressure appears exactly where work is the most routine and where people are still trying to enter the profession. And this creates a real apprenticeship problem. Companies may need fewer developers whose primary responsibility is implementing clearly defined tasks. Instead, they may need more people who can work alongside AI, understand systems, review output, and make decisions under uncertainty. That sounds reasonable. But there is one obvious problem. You usually develop those skills by doing the basic work first. And AI may allow junior developers to work on tasks that are above their current experience level. That's the opportunity. But it may also allow them to skip the struggle that helps them truly understand those tasks. And that's the risk. If you are learning to code, I don't think avoiding AI is the right answer. I think using it differently is the right answer. Ask AI to explain why it made certain decisions. Predict what the code will do before you execute it. Write your own implementation first and compare the two approaches. Break the code intentionally and then fix it. Use AI as a tutor, use it as a reviewer, use it as a debugging partner. But don't use it as vending machine that simply gives you answers. I want to make one quick detour because it's directly connected to everything I've been talking about. A big reason I'm so interested in this idea of technical judgment under delegation is that I'm currently building a course about agentic programming. The goal is to show how to work with these agents on real code bases, how to review their output, and how to understand when you can trust them and when you shouldn't. It's still not finished. I'm trying to build it properly instead of releasing it as quickly as possible. When it's ready, you'll find it in codesolved.dev. It's my site. And if you want to know where it's released, subscribe to this channel and enable notifications because I'll announce it here first. You can build an application without knowing how to code. That statement is becoming more believable every year. You can describe an idea, an AI tool can generate an interface, connect a database, create an API, and deploy a working prototype. People usually call this vibe coding, and for prototypes, experiments, and internal tools with limited risk, it can genuinely be useful. But there is another sentence that has to follow it. You cannot avoid the engineering consequences. A polished user interface can hide broken authorization. A successful test can hide an incomplete test suite. A working demo can fail under real production traffic. And clean-looking code can still expose sensitive information. The danger isn't that people are using AI to create software. The danger is deploying software that nobody can explain. Because if you cannot explain it, you probably cannot maintain it reliably. Vibe coding lowers the barrier to creating software, but it doesn't remove the need for requirements, architecture, security, testing, monitoring, or accountability. It just makes those things easier to ignore. And the easier it becomes to create software, the more important it becomes to understand whether that software should exist in the first place. So, what replaces raw coding speed? Not prompt engineer, not memorizing the newest AI model, and not accepting generated answers faster than everyone else. I think the new core skill is technical judgment under delegation. That means 5 things. You can define the problem clearly, you can provide the right context and constraints, you can inspect AI generated changes instead of accepting them automatically. You can design tests that reveal real failures. And you can decide whether a system is safe, maintainable, and ready for production. And this is exactly why system design, security, debugging, observability, and domain knowledge are becoming more valuable, not less. Someone who only knows how to generate code can eventually be replaced by another code generator. Someone who understands customers, architecture, failure scenarios, and consequences is much harder to replace. OpenAI describes this direction as harness engineering. The idea is that developers will spend less time writing application code directly and more time building tests, scaffolding, documentation, CI pipelines, and observability systems that make AI-generated software reliable and safe. In other words, future engineers may spend less time writing every individual component and more time designing systems that keep those components correct. That's not less engineering. It's engineering at a different level of abstraction. Let's go back to the example from the beginning. The AI agent built the login flow. It added password reset, it implemented rate limiting, and every test passed. Now let's ask the questions that the demo ignored. Can an attacker reuse a password reset token? Does the system reveal whether an email address already exists? Are passwords hashed correctly? What happens if two reset requests arrive at the same time? Does rate limiting still work across multiple servers? Are failed login attempts visible in monitoring? And can the team roll back the development without losing user data? The agent can make changes, but the engineer decides whether those changes are acceptable. The agent can propose a solution, but the engineer decides whether it actually satisfies the requirements. The agent can execute tests, but the engineer decides whether those tests prove anything important. And I think that's the central shift. The scarce resource is no longer the ability to produce code. The scarce resource is the ability to recognize what good software looks like and prove that a system actually meets the standard. So, what should you do in practice, whether you are learning programming or already working as a developer? I would focus on 4 things. First, learn the fundamentals deeply enough to review code. You don't need to memorize every syntax detail, but you do need to understand data structures, databases, networking, concurrency, testing, security, and system design well enough to recognize a bad solution. Second, use AI as a collaborator, not as an answer generator. Ask for a plan before you ask for code. Ask AI to identify risks, ask for multiple solutions, ask it to explain the trade-offs, and then review anything yourself. Third, become very good at verification. Write better tests, understand security boundaries, read diffs carefully, use logs and monitoring, reproduce bugs instead of guessing. The faster AI becomes at generating code, the more valuable these skills become. And fourth, build projects you can defend. Don't say the AI built it. Build something you can explain. Why did you choose this architecture? How does authentication work? What happens if the database fails? Which tests actually matter? What are the performance limits? And what would you change before deploying it to production? That's the kind of evidence that tells an employer or a client that you're not simply operating a code generator. You are an engineer. The programming profession isn't disappearing overnight, but the job description is changing. AI adoption is widespread. Trust is still limited. Productivity gains vary significantly depending on the task. Agentic tools are moving beyond autocomplete and toward autonomous pull requests. And the earliest pressure seems to be appearing exactly when new developers used to enter the profession. The future probably doesn't belong to the person who can write the most code. And I don't think it automatically belongs to the person who writes the best prompts either. It belongs to the person who can define the right problem, direct the tools, recognize mistakes that look believable, and take responsibility for the system after the demo is over. AI isn't quietly killing programming. It's quietly moving programming away from pure code production and toward judgment. From code writer to system director. And honestly, that may be one of the most important career transitions happening in software engineering right now. Has AI actually made you faster, or has it simply changed where your time goes? Let me know in the comments. And see you in the next videos. Bye.